Other pair of opposite sides are not parallel. They can be equal also. AD not parallel to BC. Types of quadrilaterals. A quadrilateral is further categorized into parallelogram, trapezium and kite based on the sides. A quadrilateral with opposite sides are parallel and equal is specially called as parallelogram. Next, a quadrilateral with one pair of opposite sides are parallel but not equal is called a trapezium. A quadrilateral with two pairs of adjacent sides are equal but not parallel is called a kite. So this is kite, right? We'll discuss the properties of kite. A, B, C, D is a kite. Then AB is equals to AD and BC is equals to CD. We're talking about here only sides. Now we talk about diagonal. When I talk about diagonals, AC perpendicular to BD. AC perpendicular to BD. Diagonals are perpendicular to each other. And also, they are suppose meeting at O. Then, BO is equals to OD. ABCD is a kite, for example. And AB is equals to AD. One pair of adjacent sides are equal. And BC is equals to CD. Other pair of adjacent sides are equal. And AC and BD are diagonals here, and they are perpendicular to each other. AC perpendicular to BD, and also BO is equals to OD. That is, one pair of diagonal is bisected. Angle B is equals to angle D as well. Arm angles are equal. Here, these two are. Suppose if I am like kite, see my head to shoulder. This is one pair of adjacent sides, and my shoulders to feet. Okay, this is longer. See, this is longer. And this is shorter. Head and it is foot, and these are arms. Now, we will talk about trapezium. A trapezium nothing but it's a quadrilateral with one pair of opposite sides are parallel but not equal. Other pair of opposite sides are not parallel. They can be equal also. AD not parallel to BC. Angle A plus angle D is 180. Which is also equals to angle B plus angle C. Why? AB parallel to CD, right? If AB parallel to CD, then BC acts as a transversal, and angle B and angle C acts as co-interior angles or allied angles. They are supplementary, no? That's why 180. And also here, D and A acts as co-interior angles. So their sum is also 180. What about diagonals then? Diagonals do not bisect and also not equal. It's a types. So we have isosceles, trapezium. So isosceles talks about two equal sides. Two sides are equal. So in triangle, two sides are equal. Then that is considered as isosceles triangle. Now isosceles trapezium also, here we only talk about the two sides again. So isosceles trapezium figure is this. Now P, Q, R, S. Now PQ parallel to SR and PS is equals to QR. See, two sides are equal. If two sides are equal, then that is called as isosceles, no? Yeah, that's why it is a trapezium with two sides are equal. So therefore it is isosceles trapezium. Properties are PQ parallel to SR but not equal. And next we talk about the other sides like PS not parallel to QR but equal. PS not parallel to QR but equal. We're done with sides now. We'll talk about angles. Angle P plus angle S is equals to 180, which is equals to angle Q plus angle R. Again, if we talk about diagonal, PR is equals to QS, which adjacent angles are equal also. Angle P is equals to angle Q and angle S is equals to angle R. Upper two and lower two angles are equal. Diagonals equal but do not bisect. We'll discuss the properties one by one. What is first property? First we talk about the main property. That is, two pairs of opposite sides are parallel and equal. One pair is AB and CD. So parallel and AB is equals to CD. So this is first property. Then second property, AD parallel to BC and AD is equals to BC. Yeah, AD is equals to BC. Parallel also, equal also. Okay. Third property, we talk about diagonals. Yeah, now we are done with sides. Diagonals bisect each other. That is, AO is equals to OC and BO is equals to OD. Diagonals are not equal. Like AC not equals to BD. Also AC not perpendicular. Not perpendicular to BD. Opposite angles equal. Diagonals do not bisect vertex angles. Parallelogram types. Properties we are done. Types. First one, a rectangle. And second one, we'll talk about rhombus. Third one, we talk about square. Okay. In rectangle, opposite sides are parallel and equal. This main property must be satisfied. I told you, right? Then only it is a parallelogram, first of all. Similarly, opposite sides, parallelogram property, main property is what? Two pairs of opposite sides are parallel and equal. So here parallel and equal, parallel and equal. That's why rectangle is a parallelogram. Now why rhombus is a parallelogram? Because here also opposite sides are parallel and equal. Understood? And square also opposite sides are parallel and equal. This is common. This is compulsory. That is main property to be satisfied in all three. Now we'll talk about parallelogram to rectangle. In a parallelogram with diagonals equal is called rectangle. Understood? We are now talking about only what is the additional property that parallelogram turns into a rectangle. That's all. Next, what is rhombus? Here parallelogram diagonals bisect but not at 90. Correct? So here also diagonals bisect. See, parallelogram with diagonals bisect at right angles. Yes. A parallelogram with diagonals equal and bisect at right angles. See, this is a parallelogram. Only diagonals are equal. This is a parallelogram. Diagonals bisect at 90 degrees. Here diagonals are not equal, but it is equal. Here diagonals bisect each other, but not at 90. But here bisect each other even at 90. Here parallelogram, diagonals are not equal and not perpendicular, but here diagonals equal and perpendicular and bisect also. Understood? So this is the major difference. The properties of each in the next class. Okay, thank you.